This is the first section of chapter 9 on trigonometric ratios, and this first section is on the cosine rule. So we're going to start by labelling up a triangle here with the angles labelled as A, B, C, capital letters, and then the side opposite an angle labelled with the same letter but with a lowercase letter. So this is the cosine rule, which is a squared equals b squared plus c squared, and that looks like Pythagoras, minus 2bc cos a. And we use this when we want to find side A. So what we're going to have in a question is we're going to have sides B and C. So we will have this side here and this side here. And then you can see from the formula that we also we need angle A. So what you have here is two sides and the angle between them to find the other third side, the other missing side. So that piece of information is stated here. Now if we rearrange this cosine rule, we get this form of the cosine rule, and we use it for when we want to find angle A. Now if we look at that information in the triangle here, you can see that we have A, B and C. That means that we would need to have the length of all three sides, so side A, side B and side C, and we're using this to find angle A. So we're using it to find this angle here, this angle. Now since the angle we're finding is angle A, look at where A is in the formula. It's this bit here. So this side must be opposite the angle we're trying to find. Then the last bit of information, this is not just for the cosine rule but for any triangle, and that is the longest side is always opposite the largest angle. So the shortest side would also be opposite to the smallest angle. Now if we think about it, in a right angle triangle, the largest angle or the longest side is the hypotenuse, and it is opposite the largest angle in a right angle triangle, which is the right angle. But this rule applies for any triangle. Example 1, we want to calculate the length of side AB in a triangle ABC, which has these lengths here and this angle. So the first thing I'm going to do is to draw a sketch. Now whether this sketch is right or not, it doesn't really matter. So I'm going to label this as A, B, C. This just helps me decide which rule I'm going to use. So I have side AC as 6.5 centimeters. Let's put this here, and side BC as 8.7 centimeters, and I have angle ACB as 100 degrees. So let's stick 100 there. This is just for the purposes of deciding which rule it's going to be. So I can see I've got two sides with the angle in between, and I need to calculate the length of the side AB, which is this third side here. So that means I'm going to be using the cosine rule to do that. So we'll just state the cosine rule. A squared equals b squared plus c squared minus 2bc cos A. Now we're not going to worry too much about the lettering here, because the letters may not actually match up with the lettering that we've got for these angles, because actually here we've got angle C and we've got cos A. So we're not going to matter too much about that. All we need to know is that AB is, or A is the side we're trying to find. Now that's AB. So it's AB squared, the length AB squared, equals the two other sides squared. Now it doesn't matter which one I do first, 6.5 squared, 8.7 squared, I'll still get the same answer. So 6.5 squared plus 8.7 squared minus 2 times what I call B, so 6.5 or 8.7, and then 8.7 or 6.5, then times by the cosine of the angle between them, which is 100 degrees. Now you could do all of this in one go in your calculator, but it's actually good practice to write down bits as you go along, just in case you make any errors. So we'll work out the 6.5 squared, which is 42.25. Then we'll do the 8.7 squared, and that's 75.69. 75.69. Then we'll do the 2 times by 6.5, times by 8.7, and that gives us 113.1, and that's going to be times by the cosine of 100. Now that gives me a long decimal on my calculator, so I'm going to keep it as cos 100 and then leave that to actually put the exact value down for my answer. Just makes things a bit easier. Right, so AB squared. Let's now work out what all of this gives us. Right, so I get long decimal 137.579, and then I'll do 6, and I'm just going to put dot 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 to show that it goes on. I'm not going to round this. I'm actually going to put the exact answer, or use the exact answer in my calculator. Now to do that, that means I need to square root this. So on my calculator, I'm just going to do square root and then press the answer button, which is right next to equals, and that way I get an exact answer, not a rounded answer. Now again, I'm going to write down the full answer here, so I'll get 11.7294. So it's probably good practice to write the 4 decimal places, and then we need to decide on a suitable degree of rounding, and normally 1 decimal place or 3 significant figures is what we'll go for. So we're going to go for 3 significant figures. That's normally what we go for in A-level maths. So we'll write AB equals 11.7, and the units are centimeters, and we rounded it to 3 significant figures. So we've worked out the length of this side. Now notice it's the longest side in the triangle, 11.7, which must mean this is the largest angle in the triangle. The 2 other angles must be smaller than 100 degrees. And we could also sort of see that, or deduce that this angle must be the smallest angle in the triangle, because this is the shortest side in this particular triangle. Example 2, find the size of the smallest angle in a triangle whose sides have length 3, 5 and 6. So we'll start with a sketch. So again, this doesn't need to be sort of an accurate sketch, but probably what I will do is I will probably put the shortest side on the shortest side of my diagram. Then it looks like this one is the next shortest, and then this one here. Now I want to find the size of the smallest angle, and that's going to be opposite the shortest side. So I need to find the size of this angle here. So we'll just write down the cosine rule for when we want to find an angle. So b squared plus c squared minus a squared all over 2bc. So again, we're not going to worry too much about the labeling of our triangle, maybe with the labeling here, and there actually isn't any labeling at the moment. But what we want to make sure is that this side here is opposite the angle that we're trying to find. So this must be A. So let's put A must equal that. And then these other 2 can be B and C. It doesn't matter which way around. But the one opposite the angle we're trying to find must be A. So the cosine of the angle that we're trying to find, we'll call that A, is equal to 5 squared plus 6 squared minus 3 squared, so the 3 must go there, divided by 2 times 5 times 6. So we've got cos A will equal 52 over 2 times 5 times 6, which is 60. So if we want to find angle A, that means we need to do the cos inverse of that 52 over 60. Now if we don't get a nice number here, any sort of fraction, then what we'd want to do is to do the cos inverse of answer, and we can still do that here. So if we do cos inverse, press the answer button, that will give us A equals 29.9264 dot dot dot. It carries on. Whenever we give angles, we normally give angles to 1 decimal place. So the angle, the smallest angle, is going to be equal to 29.9 degrees. And we'll just put there that we've done this to 1 decimal place. You could do 3 significant figures, but normally for angles we'll go for 1 decimal place. Example 3. Coast Guard Station B is 8 kilometers on a bearing of 60 degrees from Coast Guard Station A. Ship A, or A ship C, is 4.8 kilometers on a bearing of 018 degrees away from A. Calculate how far C is from B. So we definitely need a diagram here. So I think we need to start by maybe drawing where Coast Guard Station A is. And then B is 8 kilometers away on a bearing of 060 degrees. So let's draw our north line in here, since we're dealing with bearings, and we want to go around 60 degrees. So, this is only a sketch to B like this, and we know that this distance here is 8 kilometers. Then we're going to add in this other ship, ship C, which is 4.8 kilometers away on a different bearing of 18 degrees. So probably what we'll do is we'll just put here that actually this is 60 degrees here. Then ship C, 4.8 kilometers away. So we'll put C up here. Now remember, this is only a sketch, so things may not be to scale. 4.8 kilometers here, and that bearing is 018 degrees. So this is an angle of 18 degrees here. Now we want to calculate this distance here. Okay, so here's our triangle that we're going to use. Now we've got the lengths of two sides. Can we find the angle in between? Yes, we can. If we do 60 minus 18, we'll get this angle here. So this angle here is 42 degrees. So that's just this bit. So here's our cosine rule again. So again, don't worry too much about the lettering, but actually in this case the lettering does match up, because the angle A is the one that we have, and these ones we can call B and C. But don't worry too much about the lettering. Be more concerned about where the numbers go. So we're trying to find this side here, which in our diagram is labelled as side BC. So side BC squared is equal to the two sides that we do know. So that's the 4.8 squared and the 8 squared, minus 2 times 4.8 times 8 times by the cosine of the angle between those two sides, which is 42 degrees. Okay, so let's work these bits out. So we'll show our working as we go along. We're not just going to work it out all in one go. So 4.8 squared gives us 23.04. 8 squared is just 64. Then we've got 2 times by 4.8 times by 8 is going to give us 76.8. So minus 76.8 times cosine 42. So I will leave that because I know that's not going to be exact. So now I can write down the value of BC squared by working out this calculation here. So the exact value I'll get on my calculator, I'll get 29.9664 ... because it carries on. So I want to square root that. So I'll just do square root, answer button, and I get 5.4941 ... So we'll give our answer to 3 significant figures. So we'll get 5.47, and that distance, we need to put the units down. So we're working that distance there is kilometers, and then we'll just put that we've rounded this to 3 significant figures. Example 4. In this triangle ABC, we've got side AB as x, BC as x plus 2, AC is 5, and angle ABC is 60 degrees. Find the value of x. So let's start by drawing a sketch, because we want to sort of see what this looks like. So we'll call this A, B, and C here for the angles. AB is x, BC is x plus 2, and AC is 5. So these are all in centimeters. And angle ABC is 60 degrees. So we'll put 60 in here. Now we've got all 3 sides and we've got the angle. We're going to use A squared equals B squared plus C squared minus 2BC cos A. And these two sides here are going to be B and C because they're next to the angle that we know, what we'll call angle A. And this side here, the 5, is going to be A. So I'll have A squared, which is 5 squared, equals B squared, so let's call B X, plus C squared, so that's going to be X plus 2, we'll call that C squared, then minus 2 times B, which is X, times by C, which is X plus 2, times by the cosine of 60 degrees. Okay, so let's try and simplify this. So 5 squared is 25. We've got x squared. Then we need to expand these brackets here. That will give us x squared plus 2x plus 2x plus 4x plus 4. Then we need to work this out now. Cos 60, if you work it out on your calculator, is actually a half. So if you've got a half here and you've got a 2 here, you could effectively say, right, they cancel each other out. And basically all we've got then is x times by x plus 2. So if we work that out, that's going to be minus x squared, almost got caught out there, minus x squared plus 2x. Yeah, and the reason that happens, well, you could multiply it all by the 2x, but then you'll be dividing it by a half. So let's say, right, let's cancel these two out and just think about doing x times by x plus 2, and almost got caught out again. This here should be a negative because we're still multiplying by this negative here. We've basically said let's cancel out the 2 and let's cancel out the cos 60, just leaving us negative x times by x plus 2. Right, let's see what this simplifies to. So we've still got the 25. Then we got x squared plus x squared, that's 2x squared, minus x squared, so that's just x squared. Then we've got 4x minus 2x, so that's just 2x. And then we've just got the plus 4 there. So it looks like that if I take away 25 away from both sides, I've got a quadratic, so x squared plus 2x. And then take away 25 from both sides, I'll get negative 21 equals 0. Now we can at this stage use our calculator to work this out. I'm going to use the quadratic equation. So minus b, so minus 2, plus or minus the square root of b squared, so that'd be 2 squared, 4, minus 4 times a times by c, which is negative 21, all divided by 2a. So that's 2 times 1, basically 2. Now what this will give us is 2 solutions. We'll put this over here. So this simplifies to negative 1 plus root 22, and you'll get this if you use your calculator as well. And then the other value will be negative 1 minus root 22. Now we can't have a negative length. This side is x, so this solution we ignore because it doesn't make sense in the question. So we'll take this value here, and then all we want to do is to press the SD button, and we get a full answer of 3.6904 ... Again, I want to round this, 3 significant figures, so I'll have the value of x as 3.69 centimeters. So you should now be able to do exercise 9A on pages 177 to 179 of the textbook.